So let's take a look at how to find the domain of functions. So looking at the first problem, y equals x over 3x minus 1, the best way to find the domain is to first find where the function is discontinuous. And when it comes to fractions like these, they are discontinuous when the denominator equals 0. Because if you plug in a certain value and the denominator equals 0, when you divide by 0 it's undefined. So all we have to do to find the domain is to set 3x minus 1 equal to 0. So then when I add over the 1, 3x equals 1, and then x will equal 1/3. And just to double check, if I plug in x equals 1/3 into the function, we'll get 1/3 over 3 times 1/3, which is 1 minus 1. So then we get 1/3 over 0. And obviously that's undefined. So when I state my domain, I can either say x cannot equal 1/3, or I can put it in interval notation and say negative infinity, comma 1/3, and then union 1/3 to infinity. Because it shows that I can plug in any number except for 1/3, because that's where the function is discontinuous. So for number 2, we have y equals the square root of x plus the cube root of x. So in order to find the domain, remember that for even-powered radicals, like the square root or the fourth root, if you have the square root or the fourth root or the sixth root or any even root of a negative number, you'll get undefined. It's going to be undefined because the square root of -1 is I, but you cannot graph that. So that's the discontinuity there. But then for odd rooted functions, such as the cube root of x, if you have, let's say, the cube root of -1, you'll get -1. So you can still graph that function. So there is no discontinuity with odd powered functions when it comes to negative numbers. So we don't have to worry about the cube root of x because the domain of that is all real numbers. What we really have to worry about is the square root of x. And the domain is simply that x has to be greater than or equal to 0. Because if we plug in 0, we get the square root of 0, and that's obviously 0. So that can be graphed. But we cannot have a negative number like -1 or anything less than that, because then that function cannot be graphed. So we can either say x is greater than or equal to 0, or we can just have a closed bracket on the left, because we can include 0. So we're going from 0 to infinity. Those two both work for the domain.